Okay, so we can start. I will share the video recording afterwards, and yeah, if you have any questions, just please write in the typing section so I can stop and answer these. Basically, what we're going to talk about is some aspects of storage, because when we talk about storage, this can be quite confusing for some people. That's why I put the small icon here for the floppy drive, which is still being used as a storage icon. And people usually ask why. Well, it's because to differ storage from memory, to make clear that memory is not the same as storage. So RAM module is different than hard disk, right? So with storage nowadays, we can do a lot of things, and literally that's the weakest link in your data center. So it doesn't matter how good your network is or how strong your CPU. If your hard disks are crappy, then that's how good your infrastructure will be. So in fact, doesn't matter if you're going to use Ceph or the storage OS that we deployed on top of Kubernetes from before. So if your hard drives are not quite good, that's where everything will stop. So first of all, I would like to talk about the storage. I'll put this into full screen. Uh, I will tell the differences between file storage, block storage, and object storage, because this was not covered in the other slides. In the other slides, you can find more information about unified storage in general and from the perspective of system administration. But in this case, I will cover these three differences, because usually this can be quite confusing for some people, especially difference between block storage and object storage. So these are the three ways how you can store data, organize, and access, as well as present, stream, whatever you prefer to do, whether it's real-time data or is it long-term storage. So there's different mediums on which you can store this, as you know. You can use typical hard drives, you can use NVMEs, SSDs, etc., tapes. So these are some aspects to consider as well. So RAID, you can use different interfacing like SAS or SATA. So nowadays we have M.2 interfaces. So all of this is just improving on top of hardware. So first of all, what is file storage is literally what we mostly use. So when you work in your uh, personal computer at home, that's the way things are being stored in the computer, using a binary tree representation of data. So you're using a hierarchical order of the structure of folders and files. Block storage is chunks of data. They're organized and evenly sized in volumes, and object storage is data that's dispersed throughout different locations and is managed through metadata. So this metadata is very important. We will see that. The file storage is, as you know, is a classical way of managing things. This is something that that works for everyone on the daily basis mostly. So it's nothing particular. It's not quite common to see this kind of structure for production grade things in cloud, for example, because the cloud requires a little bit more specific control, as with clouds we're working with different regions, and if you have one folder in United States and another folder in Australia, then that's going to be a big problem if you have a structure like this. So accessing locations on the hard drives in different data centers through the world can be very challenging. This is quite convenient for example, network attached storages, NAS. So if something is locally connected, then it's not a problem. So it's quite a common thing to have. The file-based storage systems, they don't really scale very well, but for most daily uses, this is how it is. The block storage, on the contrary, is a little bit different, and this is where the difference between a NAS and SAN lays. The storage arrays are grouped in networks usually, and you need to use some sort of network protocol in order to transmit the data between the blocks. So this data is decoupled from the user's environment, so you don't really have the data structured in some sort of order. So this is just decoupled in different areas, and it's put on different hard disks. So a storage area can be, let's say, um, a Dell equal logic Sun. So it will have around 20 to 50 hard disks inside, and you can configure it to work as a block storage. Uh, so the block storage, actually, it's very good for big companies. So if you have a big transaction of data and huge databases, this is what you're going to use. And of course, it's a more expensive variant, and it's not something that you will consider using at home. The next is object storage. I need to correct this. The object storage is a little bit different than block storage, where data is dissected in objects. Those are small discrete units, and this is more or less flat infrastructure. So the object storage, the volumes contain metadata, which tells stuff about the data that's been stored there. So this metadata can be very detailed. For example, the video or audio that's been shot, so information about the song, who recorded the song, the bit rate of the song, the quality, etc., etc. So this metadata is very crucial when you're accessing the stuff stored in the objects, because that's how you will access them further on. So this is done through APIs, usually HTTP APIs, and this is a very common thing to use within cloud environments. Like Ceph uses object storage quite commonly, and this is done, for example, if you want to store some streams and also video and stuff like that. So the drawbacks, for example, is that the objects are not modifiable, and you will have to write the object at once. So once it's done, that's it. And the storage, the object storage also doesn't work well with traditional databases. So if you want to, because the traditional databases are modifiable quite often, this is not something that you really want to use. In that case, you will use block storage. So this is a summary, and more or less you will have the crucial differences between file, block, and object storage represented in these three figures. As you can see, in the file storage, we're using a hierarchical structure, and the data can be mapped either on a single drive or different drives, different places on the drives, etc. But with object storage, data is stored with objects. Doesn't matter on which drive, or is it on the same array, or is it in the same cloud location, in the same data center. It just matters that you're using the same metadata to describe that object. It can be a song, it can be a video file, or something like that. So Ceph is one of the things that you can use to achieve file, object, or block storage. There's other solutions like GlusterFS and different file systems. The storage OS that we used for Kubernetes also can do that, and pretty much that would be enough for what you need. But I must stress that Ceph is very reliable, and it's one of the best solutions out there, and it's very, very well supported. It started as a PhD project of, I don't remember the person's name, but he initiated this as a PhD project, and later it developed into a real thing. So Ceph is being used widely for everything. You can find it on top of bare metal containers, VMs. It's everywhere. Um, the secret in Ceph is the crush algorithm it uses in order to map data. So it's using special type of maps and hashing algorithm in order to disperse the data to different locations and read the same. So this allows for huge scaling. You know, you can have exabytes and of data, so it's quite convenient, and it's pretty much used in the biggest stuff like YouTube and Facebook. So Ceph is very very well performant file system, and also object storage, block storage, etc. Also, Ceph allows for resilience and fault tolerance. It means that if the data can't be read from one place, it can be replicated easily to another. And I must say that Ceph is the exact reason what saves our cloud many times from downfalls. So whenever there is some sort of downtime, we can always revert to the last working state using Ceph, as long as the cluster is working in high availability. That's why we're using storage clustering here. So whenever you're virtualizing storage, you should consider to use high availability clusters in case something goes wrong and you don't really lose data. That's very important. Uh, yes, so in OpenStack, this is something very common. You will find it very useful if you want to deploy your OpenStack cloud and manage the cloud. So I can stress that this is very, very important. So object storage works the way that you can instantiate something called gateway, object gateway. So this Rados gateway provides object storage with RESTful APIs. So you can use either RESTful S3 or Swift, which is for OpenStack, specifically designed. And this can work either on top of bare metal, VMs, or containers. So the Rados gateway makes sure that the data is synchronized between locations in the cloud. So if you have Amazon or I don't know, Google Cloud or something, the different locations in the world will be synchronized between the different gateways that are instantiated in the different clusters, and you will have literally the same object or the um, same thing that you want to share between these regions. And this is very good because it's optimized for throughput and capacity for I/O operations, etc. What is object storage in Ceph? What does it do actually? You can you can do everything with it, and it's very convenient for streaming audio and video 4K and highly performant requirements. So analytics also is very well performant within the object storage. So if you do big data and artificial intelligence based analytics, you should use object storage. And it's also good for disaster recovery. So if you have problems with particular disks or one of the data centers in some region goes down, the same data that's been instantiated there in different locations in the data center will be found in another data center. So you can configure mirroring, you can configure everything literally. Ceph can be quite complex as well, so we're not going to go through everything here. I will provide you the documentation, which you can find at the bottom of the slides. If you open the link, it will lead you directly to the full documentation of Ceph. And yeah, if you really want to dive deep into this, there is the possibility to do so. This is a very, very big topic. If you want to manage the different locations of data instantiated in different data centers, the object storage uses something called OSD. The OSD is a daemon that runs on each location, and it makes sure that it connects to the gateway, so it can provide information about the metadata for these objects. So this OSD runs either per disk or per location. So if you run the object storage daemon on a specific disk, you can configure that as well. You can go to that detail to say that you want to run the OSD daemon on a specific disk for a specific operation. If you have a real-time streaming database, you would like to have a high input-output performance of the disk. So perhaps you will know on which disk and which file system to use, and put that real-time streaming on a SSD. And more unreliable data you can put on some disk that works in RAID, so you can have mirroring or things like that. So it's very, very customizable, and you can go in very big granularity here. The objects, they live in something called librados, which is the Rados Gateway library, and these objects are stored directly in the locations where your data will be. So this metadata is accessible through the Ceph command line or a dashboard. I will show that later as well. So the difference between maintaining the objects and a specific directory can be big. So if you want to do something like this and maintain a whole directory, then you're gonna do it through the object. Or for example, you can have a two-stage lookup, or you can have directories that are scalable, or directories that get out of sync. So this can be quite a problem if you want to do this manually. So what Ceph does, it employs algorithm to manage this automatically for you. Because if you want to calculate placement of data on specific locations, this is impossible if you work with big data. So you don't really want to do this. If I want one song to go on this hard disk, if I want a video to go there, if I want a document on another disk like this one here, that's something you're never gonna do. So solutions like this, they provide a more automated way how to place data like that. So you can have, for example, two-step placement, more or less automated way of clustering of the data. But in order to manage this, you really need something comprehensive. You need to build so-called maps in order to know where the data is at which location. Otherwise, you're gonna get lost. So the Ceph object gateway creates pools, and these pools are your nodes in which will become part of your storage agenda. So in the pools, you will instantiate so-called monitors, and these monitors literally do the job as what they're called for. They monitor for disks and physical hardware or virtual storage devices that are put there in order for you to send the data, write it, and get the procedure as described in this diagram to confirm that the data is written and that the client can have access to that specific location at any time. So the Ceph client, what it does, it binds to the Linux kernel. So in the client where it's instantiated, it communicates directly with the gateway, and the monitor that's monitoring the actual disks and the file systems, it will send information to the client via the daemon. So it's client server architecture, more or less. And this works on different platforms. So you can have it on CentOS, on Debian, etc. The pools literally are classified in service pools, and you have also policy. So in the service pools, you will have roots, realms, zone groups, and zone configuration. You have control, garbage collection, logs. I'm not going to go through all of this because it's going to be very long if we go through every detail. So I'll just number the stuff so you can have a approximate image of what's going on, because Ceph is a very complicated system, I must say. So the service pools, they're using the crash algorithm. I'll say something about it a bit later, for data durability, and it can use the same hierarchy of the crash algorithm for only for the service pools. You can do the same also for the policy placement. So the instantiation of policies, it will allow you for different hardware configuration and characteristics, what I mentioned before. If you want to use normal disk or SSD or NVMe for different purposes, so you can literally configure this before you start using the Ceph system. Well, I think there are best practices, of course, as everywhere else. I managed to read a little bit about this. So if you go to this link, which I provided in the official documentation of Ceph, they recommend what kind of hardware you should use in order to have a good cluster, storage cluster. So uh, the cluster can be good if your hardware is good. If you don't have good disks, then you'll say goodbye. So it's not gonna work. So the drives should be faster. They should be reliable, better quality, possibly new ones, and you should replace them as much as it's possible because failure in drives results in failure of everything else. So you will need to have a good network as well. The network should have low latency and it should be very high in bandwidth and low in jitter. For example, just an example, 10 gigabit network inside your storage cluster is the literal minimum for production grade storage clusters. So average speed of network will be 40 gigabits per second for the storage because the access, you don't know how much the storage will be accessed at what particular time. So you don't really need network bottlenecks when it comes to accessing your storage, and also security. So there's a lot of considerations. So these recommendations are given here. You can go through detail on the link. Drives literally can be you can use SAS drives over SATA drives, for example. You can use higher RPM drives. So you should disable the cache on the drive because, yeah, the cache uses some sort of, it can be like the SSHDs. They're using SSD to cache the data inside the small non-volatile memory and read from it if it's being used more often. So these kind of things can impede the work of clusters. So there's other ways how the storage is optimized in clustered environment. So, for example, if you're using hardware versus software, RAID controllers, so etc. So these things should be also all considered. Yeah, as I mentioned, SSDs, they play important performance role. So if you don't have SSD nowadays in a data center, then nothing's gonna work. Literally, if you have high performance demands for read and write operations, then definitely you need to have SSDs. Um, the crush algorithm that I mentioned before, this is a hashing algorithm, and it's called controlled replication under scalable hashing. So this algorithm just manages where and how the data is being stored and distributed in the cluster. So if you want to read more thoroughly about this, there is a very, very good explanation on the website of Red Hat, or of course the main documentation of Ceph. But this algorithm is not simple. So the person who developed this, he went through quite a lot of venture in order to achieve this. And this is very good. So the crush algorithm creates maps, and this crush maps is something that you can customize, and you can make according to your environment. So you can tailor them as the way you want. Depends, like I mentioned before, if you want some data to be on SSD, another data to be on hard disk, or in a RAID array, etc. So this is quite a good thing. So what does the crush do? I'll go through the next picture. I think this is gonna explain better, and I'll come back to this one. The objects are being hashed through the algorithm, and the algorithm actually decides where to put the actual objects. So this is done based on the monitoring principle, because the cluster needs to retrieve some sort of state. So the cluster gets a state, and it gives the state back to the hashing function, to the map. And when you're sending objects, this will decide where this is gonna go, in which place. So roughly something like that. If that's not comprehensive enough, then, for example, um, if you have folder full of Word documents, so they all belong in a zip file, this will be considered as a single file, but it can be also dispersed. Or you can have like 10 different zip files with lots of things inside. It doesn't really matter. What matters is that the end storage device, it can have not so very good, let's say, defragmentation factor. So this can be a downside for the crash map, and the crash map will decide not to put things there at that particular moment. Maybe later, but in this particular moment when we request it, not, because the monitoring that's been performed on these physical drives, it will say that that location is not viable and not desirable at that moment, so it should be put somewhere else. So more or less something like that. Uh, the devices that fail also, all of this is monitored. It's not only the desirable location on the particular hard disk, but it's also the state. If the hard disk is not functioning very well, because every disk has this smart function. This smart function is telling the health of the drive. So if the drive is getting into bad state or the health is getting lower, this is going to be reported, and the cluster will know literally which drive is better and which is not. So it can be replaced afterwards. When the drive is starting to fail, this location that's marked in green, it will be mapped to another drive temporarily until it's moved to maybe another one. So you can have a replicated state of that particular object. So in order to prevent loss of data, this particular portion is going to be replicated to one or two different places. So this is the beauty of the algorithm, and therein the complexity, of course. Um, if you want to go deeper in this, I'm not gonna spend too much time of your day, so perhaps you have uh, to do the projects and homeworks and get ready for exams. So I'm not gonna go into the depths of the crash algorithm. So this is more or less how it does. We're gonna talk about deploying Ceph, and I'll just try to kickstart you in with this. If you want to explore, feel free to do so, because yeah, Ceph is a very, very big system, so we can't really cover everything. I will show you how you can do this on bare metal and also on Kubernetes. There is something also new, something called Cephadm. So this is a very new tool, because it offers some sort of automated way to deploy Ceph. Before that, we were installing Ceph manually, and this really takes a lot of time. I have created one document in which all of this is described, and I will share that on Canvas, so you can try to deploy Ceph manually if you will. And more or less, it's literally installing the clients and the daemons. So you have to create user accounts for Ceph, and you have to have enabled passwordless authentication between your hosts. This is very important. So make sure that you use SSH copy ID in order to enable passwordless authentication between the hosts. Otherwise, in order to authenticate the Ceph daemon um, with the master, then you will have a problem, because Ceph doesn't know to request password for the SSH. It just sends a public key, and it expects that authentication is done. So make sure that you have passwordless authentication enabled. So this applies also for bare metal instantiations, or if you have something like configuration management and provisioners. So I believe that if you're using Puppet or Chef or any of the provisioners, already this is something that you have done. There is a way how to deploy Ceph with Ansible. I also provided a link for this. I think it's a YouTube video, and it's coming directly from a person who develops the Ceph system. Uh, so you can try that. It's very easy. but this is something also that's not been considered anymore, because you know, when you're doing deployment with a third-party tool like Ansible or like MLN or anything like this, it's just another tool that you need to learn and you need to take care about. So there's more things that can go wrong. That's why the Ceph community has developed the Cephadm tool for you to deploy the Ceph cluster directly. And this is very, very simple. I will show you later. Except if you deploy Ceph in Kubernetes, then this is not going to be for you. This is something that that's done directly on the bare metal or in other instances. The Ceph admin tool, it deploys a container. So in the container, you will have a resilient form of runtime. So it doesn't matter if the system goes down, the containers will always come back. So trust me, you will have harder time to delete the environment than to turn it up, because the containers will just keep coming back, and the Ceph system will just keep running no matter what you do. So this is configured. It's a script, so to say, literally a script, which does everything for you. So this script is on GitHub. We will download it, and you just run it and define the cluster nodes, and that's it. So the Ceph admin uses an orchestrator. So this orchestrator is literally something like Kubernetes. So it automatically deploys containers not only on your local host but on the other nodes, the remote nodes. So this is very good, and you don't need any other tool. You don't need Salt or Ansible or any tool to manage this. It's just out of the box. You know, these tools are considered legacy, as you can see. So Ceph Ansible or Ceph deploy, which was a typical tool for deploying Ceph, and this is a very manual approach. These are considered legacy tools. So in order to avoid using stuff like that and to have to avoid operating system dependencies, these things are being deployed in containers. There is also a comprehensive manual for the Ceph admin, and also in the official documentation there is a lot about this. But when you run the script, if you run help, it will show you a lot of things how you can do in order to run Ceph with Cephadm. But if you have a necessity to run Ceph in Kubernetes, then there's also a few ways how you can do this. There is more manual way and there is automated way. The automated way is by using Rook. Rook is a special orchestrator for virtualized storage for Kubernetes clusters. So if you use a manual approach, then more or less you're going to have to do similar things like you did before. You have to install the Ceph cluster first, and then you have to tell Kubernetes how to consume this, how to use the cluster. You're going to have to map locations of the disks and things like that. It's really a long process. I have also covered this in a Word document for you, so you can try if you want. But if you really want just to go and get it running without any headaches, you should use Rook. This is the link towards the orchestrator, but Rook has a specific website. I think it was rook.io. So it's tightly integrated with Kubernetes, and this is the way things are done for managing Kubernetes storage. You don't really have to use it, but it's good to know. So it will save you a lot of time if you want to just kickstart and make things running out of the box. Rook also allows you for templates. So you can use storage templates for clusters, and we can see how we can run this later. So I'll just go ahead and show you some short demos, so you can try yourself later and see if you like to use Ceph, or you can use anything. It doesn't really matter. You can use Gluster FS if you have more experience with that. You can use anything you will. In the end, finally, I will provide you these two links so you can check them if you need to deploy this in a different way. There is a very nice tutorial how you can deploy Ceph cluster. It's for Red Hat on the Red Hat server, but doesn't really matter because this works on anything. And it's by using Ansible. So we can't really show this deployment on bare metal. Why? Because we're working on top of OpenStack and we're using virtual machines. So the virtual machines already have the storage mapped through SCSI protocol or something else. I'm not sure what it does in the backend there. I remember we have some sense. So in any case, the storage is virtualized, so I can't really show you physically how this is done on a real hard disk. So in any case, this is good to see. And on this link, you will have Puppet module for Ceph, so you can try this if you already have something with Puppet. I'm not sure if this is maintained because many of these things are just kicked out. As you know, Ceph is evolving and they're just employing some new tools for management and orchestration. And these tools are proving to be quite better than what already existed. So you can try for the sake of learning. It's not going to hurt, so just feel free to do so. So that's it for the lecture. I will share the slides and I will just show you quickly about the document that I promised. Let me just switch the screen. I think it's this one. Yes, so I have created a document for deploying this, and I will also record a special video for Rook in the end, because this document is going to be divided into 4 ways. So you will have A, B, C, D, and in A you will have the manual way how to deploy this. So as you can see, first you need to, if you want to have like a 4-node Ceph, so you can have 2 or 3, doesn't really matter. There are recommendations how many nodes you need for high availability. So there are rules, of course. However, you will need to use the Ceph deploy tool, which you need to install as well. So you can get that from the link, add the key, and install it. And then you have to set up the nodes. So first you need to set up NTP protocol on all the nodes. So make sure that you have synchronized the nodes. Otherwise, without synchronization, the storage can go way ahead. You know, it's very important to have NTP installed everywhere. Then you have to have SSH running on all nodes and passwordless authentication. So all these nodes should be just accessible without any issue. So with this, I think you've done already by using SSH copy ID. Then to deploy the cluster, you need to create a user, blah, blah, blah. So this is a cumbersome process. It's manual, and this is how it was done before. So in order to bypass this, we will use this Cephadm tool, and we will use Rook to install it on top of Kubernetes, because it doesn't matter if you use Kubernetes or anything. This was the way how things were done. So manually, you need to install everything. You need to make sure the ports are open. So Ceph uses some specific ports for the object storage daemons, particularly 6789. I think it was by default. And this is the range of ports that it can be configured to use. You can check that on this link here. Every operating system has a different way how these things are being done, and this is all covered in the documentation. So if you're using something different than Ubuntu, there is definitely a instruction for this, so you can just check it. And yeah, make sure the firewalls are not blocking anything, so the nodes can communicate with each other, more or less like Kubernetes cluster. This is a storage cluster. So then you have to create directories and etc., etc. This is the way it's being done, but in order to bypass this, there is a way how you can deploy this into Kubernetes. So this is more or less the manual approach, and I have also covered the automated way, so you can do that. So if you want to try all of that, it's here. So you can apply this namespaces and deployments, and it will just tell Kubernetes to use what we deployed before. So you guess you can see this is a very long process. Uh, the the overall process of this is how to instantiate RBD, which is um, CEPH-RBD is for block storage. But if you want to use CEPHES, the file system, which is common, very common, very similar to what we used for persistent storage with Storage OS, you can follow this tutorial to provision CEPHES. This is coming from the official website from Kubernetes. It's not difficult, it's quite straightforward, but there are other ways how you can do that. This is how you can bootstrap it with Cephadm, and more or less this is all you need to do. So you just download the script, you make a directory in etc ceph, and you run the script, and you put your IP address of the machine where you're running it. So in fact, you don't really need to do anything else. Later, you just have to add the nodes. You can do that through a dashboard, or you can do it through console. So I will show this as well. So no worries. However, taking this down, it can be a problem for you. So you're gonna have to delete literally everything that the script created, so you can take down the cluster. Otherwise, the cluster is designed to be deathless, so it will just keep coming back no matter what you do. If you delete the containers, they will come back. If you delete the image for the containers the bootstrap will just pull the image back from the repository, and it will run the containers back again. So the cluster will be alive no matter what you do. So it's literally a god. So this is how things are done on bare metal. This is not going to work for Kubernetes. It can, because if you know how to point out the Kubernetes cluster to use what's been deployed underneath, then that's not a problem. But for deploying Cephadm, this is done directly on bare metal, more or less. I will show it nevertheless, so you can have an overview of how this is done. Another thing I will show you is how to use Rook to deploy it on Kubernetes. And this is done in 2 or 3 commands. So I will just cover this in the document and share it with you. You can try it if you have the cluster running, because I will show you the documentation of Rook. Let me change the screen. I think it was this one. Yeah. So this is the documentation of Rook. If you visit the rook.io website, you have everything there. So what you need to literally do to kickstart the basic cluster, you can just clone the repository. 1.3 is the latest release, and there are some example files there which you can just apply. If you have a running Kubernetes cluster, as I expect you have, you can just apply the cluster directly. So these 3 files, and that's it. You will have Ceph running. Then you can configure that. You can configure a dashboard and etc. So it's quite very simple to do this with Orchestrator rather than go manual way. I will share all of this, of course, and more links. I will finalize the documentation after I show you how you can do this with Cephadm. So for the time being, I will just switch to the console. If you like, you can try it. If you don't have to try this, so you can just observe it, and it's something that's quite straightforward. So I'll just switch to the terminal. Let me check. I think it's this one. Yep. So if you check the terminal, it's the same I used before for deploying the Kubernetes cluster. And in this case, I have the same nodes. So if I ping the nodes, I get a response. It's important to to get a response from the nodes. Otherwise, you're gonna have problems with the cluster. So I have 3 nodes: EPC, worker 1, and worker 2. So when I deploy a cluster, I'll just add a node here, and I will just add later these 2 nodes into the cluster. So I'll show you how this is done. So first of all, what you need to do, you need to make sure that you have passwordless SSH. Again, I will stress that, because if you want to SSH to the worker node like this, then you have to use SSH copy ID. The same applies for worker 2. So this is something you have to do before anything else, before you start anything. Then another thing you need to do is apt-get install NTP. In this instance, it's installed already. So you do this on all 3 nodes. You SSH to the other nodes you have, and also you install NTP. You can configure it to use the same server. I think it's already configured. So you don't probably just have to install it. You don't need to configure anything. NTP will just use the best server. So if you're running this from the same cloud, it's not going to be a problem. If you're running the nodes in 3 different clouds in 3 different regions in the world, then you're going to have to choose the best time server you want to use for all 3 nodes, and to use the same one so they can be in sync. Otherwise, the cluster is not going to work. It will be out of sync, and this is a big issue. You don't really know which data is saved when and where. So it's very important to make sure that the time synchronization is set correct. Okay, so what we need to do next is just to download the script and run the cluster. So I'll just copy this from the website. I will share this as well. So I just curl the link that's provided. It's a GitHub location for the Cephadm tool, and it will just download a script. I think it will name it Cephadm like this as well. Yeah, this is the exact one. So we need to make it executable. Plus X Cephadmin. So this is the script we're going to use to run stuff. You can add it as a in the path variable, so you don't have to be in this location to run the script. So you can run it from anywhere if you want to do that. But I'll just save some time and show you how easily things are being bootstrappable with this. It's crazily easy. So you can use the script to run installations and everything else. But before that, you need to make a directory, because there is no directory in etc, which we will call Ceph. So in this directory, you will bootstrap monitor. So first, we need to run this node. So this node's IP is 172.16.0.10. So we will use this node as a starting point. So what we need to do is, as you can note, I'm running the script directly from this directory. So I'm not putting it in environmental variable. We can do that, so it doesn't really matter. Bootstrap monitor IP and 216.0.10, the IP address of this particular machine. And you just press enter and it will start running. I really hope that there is no error, because I deleted things before, so I don't know if this is gonna show any error right now. In any case, it will start a cluster, so to say, a single node cluster. So it checks if some stuff are installed. If not, it will try to install them. And what is also important, it assigns ID for the cluster. This ID is something you will use to perform commands through the Cephadm tool, or also to perform remote commands to the other nodes. So what this script does is it starts a cluster, and also it creates some keys, like these keys are put also in the directory we just created before in the previous step. So these keys are going to be used for passwordless authentication towards the nodes that are going to be members of the cluster. So I really hope this is going to end without any error. If you're starting this from scratch, it will just work out without a problem. But note that this procedure is not what you need for using Ceph for Kubernetes. It can work out for your particular VMs that you're running it on, or for the Puppet. So there are ways how you can connect this to the infrastructure that you already have. But everything else has its own way how things are being run, because it's just going to save you time. Although there are ways how you can fix it, how you can make it work for what you have. So it can be a longer road. Anyway, this is creating a monitor. It's creating a monitoring map. So this crash algorithm map that you can edit later. So it's just starting a minimal configured cluster, more or less. So it can kick you start. This is all from the official documentation. I will provide links, and sure, you can try this. You can run the orchestrator commands through the Cephadm, because you don't really have the Ceph tools installed. Ceph uses common tooling, um, so this we don't have installed on the VMs at all. So in order to run these tools, you have to go through the orchestrator. So when you enter in the Cephadm shell, it's more or less like entering in a container, because what this does, it really runs a Docker container. So it runs a container in the network that we're using, the host network, and using these ports, as you can see. So the container will be running here, and later when we connect the remote nodes, the bootstrapper will run containers there. This is quite convenient. It saves you a lot of time. The manual steps for deploying Ceph will just take you a good portion of the day. Yesterday I tried some things to deploy manually, because I have forgotten a lot of things about this. When we were deploying the cloud, we were doing this using something called Fuel Orchestrator. Fuel is specially designed orchestrators for deploying OpenStack, and it's not maintained anymore, I think, because it uses a combination of Chef, Puppet, and something called Cobbler. So these are dinosaur things, it's not something that anybody's using nowadays, rarely. So some things are dying off and some things are being maintained. So okay, so yeah, as you can see, this finished. Now the dashboard is available on the link here. So if you want to access this, you're gonna have to redirect SSH port from your local machine towards the VM, like we did in the Kubernetes instance. Right, and to access the shell, you need to copy paste this ID. I think you just need to run this once, and it just copies the randomly generated ID number into the etc ceph.conf file. So if I want to access the shell and run ceph commands, I have to use this. I'll copy paste that, because now, as you can see, there is no ceph commands. It will say ceph not found. It can be installed with ceph common. So we don't really need to install anything. I'll just paste this, and it will enter the shell. So this takes out the ID of the container, and it uses the stuff that are instantiated there. So you can run this literally directly. So if I go, for example, ceph -s, it will show you the cluster state. So it says health warning. This is something always to watch. The only way you should relax is when it says health okay. So it means that we don't have object storage daemons running. In order to have high availability, and you have to have more than 3 OSDs running in different hosts. So we're not going to fulfill this quota anyway because we have only 2 machines, but nevertheless, this is something to look for. So what can we do next? We can run a couple of commands, and actually I can show you the dashboard. So I'll just run another terminal, which is my local PC. I'll show you this. Let me switch to that screen. So this is my local PC, and I'll just redirect 8443. So I think I can use this command actually. I'll just put here 001, and I'll just redirect this to my VM. So what I did, I established a SSH tunnel, which will make sure I can access this on localhost on my browser on the same port. This uses HTTPS. So let me switch to that screen from Google Chrome. Right. So if we go HTTPS 127 or localhost 8443, this is where the dashboard is running. So it will show you the default password. The default password is represented in the finalized message. So this is the password it generated, and the user is admin. So we go back to the screen. Use admin, you paste that password, and it will prompt you to paste the old password and change it. So I'll just put some another password. Maybe that's good. Yeah, it's quite good. Shows if everything's fine. Admin and the new password. So that's it. This is more or less everything. So in order to add nodes, what you need to do is you need to copy ID another key that's going to be used for the Ceph cluster per se, because it's not going to be enough that you just add your own copy ID from the machine itself, because the keys are generated in the actual directory that we created for the Ceph cluster. So to do that, we're gonna need to copy ID these keys. I will show you where they are. So we need to just SSH copy ID -f, I think it was -I, etc ceph.pub. Does it exist? Ceph.com, ceph.keyring. Okay, it doesn't exist, so we need to generate this. To expand the cluster, we need to copy this. So to generate that, let me check if we just yeah, all right, this is why it doesn't exist, because we were in the container, so we need to access the container. When you enter the shell like this, you enter in the container, and then you can check the cluster itself, but you need to access this in order to go back to your VM. So you can, if we go now to etc ceph, here we will have the public key already generated. If it's not generated, then you can generate it by entering back in the shell, and you just type ceph admin get ssh public key, and this will generate a key. So when you get out and come back here, it will be here. So this key we need to copy to the remote nodes. This is a little bit of manual step. There's ways how you can use provisioners to do this more automatically, but you don't really need to do so. So you can just copy it. So if we just go SSH copy ID -f, I think it was -I, etc ceph. So we are already in that directory. Copy that key to your remote host. So I'll just type worker1. So note that if you want to access your nodes like this, you need to put them in your etc hosts file. So that's gonna be copied there. If I go cat etc hosts, I'll just show you. Yeah, so if you want to use your host names of the nodes, you can add something like this, the IP of your node and the host. So it's gonna be more convenient for you to access these two nodes that you have. The same we have to do with the other node. So we just, I'll copy it to worker2. So both keys are there. And then we can add this in the dashboard. I'll go back to the dashboard. So if you go in cluster and if you go in hosts, it shows 500 internal server error. There's a couple of reasons why this does. It's because the dashboard is either conflicting with the Grafana I have from before, or it has to do also something with the Prometheus, because this uses also Prometheus. So make sure that you don't have anything like that running in the background. This has, because the Kubernetes cluster is running and uses Grafana and Prometheus for monitoring. So make sure that it's clean if you want to run this on bare metal. So in any case, to add the hosts, you can add them here. So I'll just add worker1 and create the host. So it will add it to the pool. The host is created. This you can ignore. So 500 is nothing. Then you can create worker2, and it will add the two hosts in the pool. So if you wait for some time, the services that are running here, they will be instantiated there, because this orchestrator that's being built in, it automatically runs the stuff there. So if we go, let me show you quickly. I mean, this is it. So you can have 3, 4, 5 nodes, and they will just be part of the cluster. So you have 3 hosts. You see there is still nothing running. It takes a little bit of time to pull the containers from the repository and run them on the remote host. If I go back to the terminal, I'll just search for the containers that are running the Ceph. You can check here that on the main, this is the main server, the initial machine. You have a couple of containers running. So one of them is the manager. The other is the monitor, which pulls information, logging, and you have monitoring. So alert manager with Grafana and Prometheus. So this is more or less the problem why the 500 error is coming, because I have Grafana running already for the Kubernetes cluster. So in order to bypass this, when you run the bootstrapping, when we run this command, you can pass an argument. Yeah, you can pass an argument. I think it was no monitoring or something like that. Let me check on the official documentation. So in any case, you can pass an argument to tell the actual deployment to skip running Prometheus and Grafana. So there's a lot of let me check. I think it was Cephadm help. If you do this, we need to be root because there's where my file is. That's why it's good to have this in environmental variable. If you go help, yeah, right. So if you go bootstrap, it will show you. So, right, if you paste this argument while you're bootstrapping, it will not provision the monitoring stack, Prometheus, Grafana, Alert Manager, Node Exporter. So then you will not have that error. So it doesn't really matter. You can also skip the dashboard if you want to proceed with command line. So all the things you can run also through the command line. Sure, that's how we were doing things so far. But since this is quite convenient, then why not? I will SSH to the worker one also to show you the containers running there. Ceph, anything that contains Ceph. So you can see that we have 3 Docker containers running, and these are the monitor, the manager, and the logging. So it's literally the resilient part of the cluster. So if you delete these containers, they will come back. So they're not going to be kicked out. In order to remove everything, you need to first stop the containers. You need to delete the directory. Var lib ceph. You also need to delete etc. This is something on the main node. You need to delete etc ceph on the main node, and you need to delete these 3 containers afterwards. And then also you need to delete the images. Actually, the image. So there is only one image that's running. It's this one. So when you finish, you just docker remove image and paste the ID. So then, yeah, the bootstrap will be over. You can deprovision the cluster still, but I think that some of these containers, they will not be removed. You know, they will just be there and they will take space. So the image is 1 gigabyte itself. So if you really want to delete it, it's good to free up the space. It's not used anyway. And that's it. So if we go back to the dashboard, you can see that I think already it should be provisioned. So I'll just refresh this. 3 monitors. They're in quorum. There is some health warning. Yeah, it will warn you. You see that there is a clock skew detected, that they're not in real synchronization. So this is very good. It tells you that you don't really have OSDs. You should make some OSDs. It means that the data availability will be reduced. You have inactive page, so the paging is not properly configured. It's gonna tell you everything. So all of this you can fix as you go, and that's it. This is more or less kickstart how you can run stuff. You can add. You can create different pools. You have read-write monitoring, how much you read and write. You can monitor the cluster, you can configure the crush map, etc., etc. So this is very good stuff. Yeah, for Kubernetes, you don't really need anything special. You just need a Rook, and in order to run Rook, I will show you the required documentation. I already did. Yeah, this is the site. So it will kickstart you in the cluster. So then you can provision either block mode, you can provision object storage, or you can do file storage. So if you click on this, it will lead you towards the section where it explains how you can create object storage for the cluster. So more or less it's ready, so you don't really have to write these things yourself. So it's very detailed, and you can do anything you want even with this. Right. So in your instance, if you're running this through the Kubernetes, this is what you're gonna need. So more or less, you just clone the repository and go to the cluster examples Kubernetes and for Ceph, because Rook also has templates for NFS servers, Cockroach DB clusters, and Cassandra clusters. So Edge FS data fabric. So it's not only for Ceph. It will. It's more or less a type of orchestrator for different types of storage. In any case, you can find ready files there. You can check what they have. You can configure them. I will just clone this and I will go in so I can show you. But before I deploy this, I need to remove the cluster that's been created here. So I'm not going to do that. It will take a longer time. So this is running already. I'll go back to the main node and let me just switch to the terminal. This is the main node, and I will clone the repository from the link I pasted. It will just pull the latest version, 1.3. So if I go to Rook, this is the directory. And if you go to cluster, you have examples. You can use Helm also to deploy charts. This is also very good because, as we showed before, with Helm you can just have stuff with one button press. So very convenient. If you go to examples, it will give you some sample templates. This is for Kubernetes. There is also for CoreOS. CoreOS is a special distribution of container Linux. So it's the minimal distribution of Linux. You can check that also. It's very cool. So you see, you have templates for EdgeFS, Cockroach DB. Cockroach DB is also non-relational database. Cassandra is something like MariaDB. There's a lot of ways you can create the storage. NFS, if you want to have some storage server. So yeah, if you plan to do something about the project with this is also quite good. If we go to Ceph, you will find templates here for running some stuff like also NFS with Ceph, a ready cluster. So if we open the cluster YAML file, it's a ready template. So you can configure this template to use how many monitors? 3. Allow multiple per node if you want, 2 or 3. So you don't really need to run multiple monitors in one node. Dashboard, it will be enabled. You know, the dashboard that we just installed with Cephadm. So Rook will also just do that all automatically. If it's put in this file, it will be installed. So I'm not gonna do this because it will conflict with the already installed cluster. But for my Kubernetes cluster, this is what I need. So in order to do that, you just have to create. So just I will show you kubectl create -f common.yaml. So first you start there. Let me check what's in there. This is literally gonna kickstart a namespace, and it will start a Ceph cluster. As you can see, it will name it Ceph cluster, and yeah, it starts a deployment. So this is a very long YAML file. Take a look how big this is. This is saving you days of work, literally. Imagine you have to do this all manually. So using templates is a lifesaver, especially when you run something in production and you need things running out of the box. This is a lifesaver. Then you can configure, you can run a dashboard, create a dashboard that's external. It will run on some external site, and it can use HTTPS if you have configured certificates. So literally everything you want to do. If you have Ceph cluster that's running, let's say, in Amazon Cloud, you can configure Rados gateway that's external, and it connects to the gateway there. And then this, given that, of course, you have NTP installed here and there on the same server, it will synchronize the data between that storage pool and the one that's on this machine. And this is all with Kubernetes. This is not anything on bare metal, so it can be anywhere in a container or doesn't really matter. So that's all you need to do. You just create the common, you just create the cluster, and you have to run the operator. I'll show you what's in the operator in this one. There is also operator for OpenShift. If you're using OpenShift, this platform as a service from Red Hat, operator.yaml. So in the operator, it will start a configuration for the container storage interface. The container storage interface is a specialized driver that's using either RBD or it's using object storage or file CEPHES, the file system for containers. So this is a very important part. If you don't install this, it's not going to work. So these are the three things you need to start: the deployment for the operator, the common, and the cluster itself, and everything will be running. So you just apply these three things. I will share this also with you. Let me check quickly. kubectl get pods -a. See, this is my Kubernetes cluster. If you want to run this as we run it with the Cephadm on Kubernetes, you first have to remove your storage OS. You don't really have to, but for just avoiding confusion, it's good to remove this because literally you're gonna have the same thing. Ceph does the same like storage OS, so you don't need two types of file systems. You can remove the storage OS from your Kubernetes cluster before you proceed, and just do this, and it will be fine. You will have the same done like we did before in Kubernetes. You can access the dashboard normally and perform all the tasks accordingly. So that should be it. If there are any questions, yeah, feel free to proceed and email. I hope everything goes well also with the projects. So you let me know if there are any problems so we can address these. So soon we will come to you about the course evaluation, and we will give you more information about the exam. There's still time, of course, but better to do it earlier rather than later. I'm not really sure how the administrative things are in terms of um, postponing exams or stuff like that. So we'll have to consult about this, and in any case, you will be informed. So I know that there is still plenty of time left, so you have time to study, so no worries. If there's anything I can help, just feel free to ask anytime. I can stop the recording here.